Okay, so I think, have you seen this formula before? Drag force. Yeah. Drag force equals to half times the rho, which is the air density times the velocity squared, times the drag coefficient and the area. So the drag coefficient here, is it just the skin friction drag or the pressure drag, or is it both together? Both, right? So the drag coefficient that you see here is actually a combination of both the skin friction and also the pressure drag. Okay? And also, it also depends on the frontal area. So if your frontal area is bigger, which means that your drag force will be larger. Alright? So now question. Okay, so if I increase the, okay, so what's the relationship between the velocity and the drag, the coefficient and also the car velocity here? Or in other words, towards the drag force. How does the velocity and the coefficient affect the drag force? Any idea? Yes, correct. Velocity is lower, then the drag force is lower. Yeah, correct. And same goes to the drag coefficient. If it's lower, the drag force will be lower. Okay. So some design consideration here is that you must try to reduce the frontal area, but later on we will introduce another formula on how much do you reduce it. Okay, it cannot be too sharp. If it's too sharp, it will tend to break. Okay, and it's not stable. Use a smooth nose, gradual body transition, avoid flat vertical surfaces, alright? And also smooth the rear body to reduce the weight. Okay, so all these are things that you're able to do to reduce the drag force. And also the drag force increases with the square of the velocity. Okay, so which means that when the car becomes twice as fast, what happens to the drag? It becomes about 4 times larger. Okay, so you must pay really a lot of attention to the drag force. Okay, in that case, drag coefficient. Okay, so in order to calculate the drag coefficient, you must use the CFD software. But just a brief idea on drag coefficient is that it describes how aerodynamic the shape is. Okay. So if your shape is not aerodynamic, means that your drag coefficient will be higher. Okay. So in that case, if a low drag coefficient, that means that it allows the shape flow, the air flow more easily. Okay, which means that your car will be faster. So your aim is to have a low drag coefficient. Okay. So this is something similar as what we mentioned just now, the design consideration. So what, any questions? So here we mainly talk about the drag force and what contributes to the drag. So now we go into more in detail how the drag is formed. Have you been exposed to this Reynolds number? Something new?
Yes.
Okay, yeah, because we actually learned this in our undergraduate course in physics. So you are learning something that undergraduates are learning. Okay, Reynolds number. So what is a Reynolds number? Okay, Reynolds number basically is a value that defines whether a flow is laminar or turbulent. Okay, so Reynolds number actually depends on the velocity. So which means that the car starting, it will be laminar. After that, the flow might transition to turbulent. Okay, so a low Reynolds number, basically a laminar flow, which means that the viscous effects are more dominant. Okay, what this means is that your skin friction drag here at low Reynolds number is more important. Okay, if your flow becomes turbulent, your initial effect becomes more dominant, then your weight and your pressure drag becomes more dominant. Okay, so in other words, laminar what's more important is the skin friction drag. But for turbulent, high Reynolds number, the pressure drag is more dominant here. Okay. But when you're doing stem car racing, it's usually quite fast. You're going about average 18 meters per second. So you finish your race around 1 to 1.3 seconds. So usually your car will be under from the laminar, it will transition to the turbulent. So in other words, skin friction drag is not so important, but it might give you extra edge. But the more important one is the pressure drag. Okay. So when we talk about the Reynolds number, we talk about the boundary layer. Okay, I think this is something new to you also because this is what we learned in our second year, third year. So what Reynolds number is that you imagine your surface here, alright? Any surface of table. If anytime when there's a wind or a fluid, a water or an air passing through, you have a boundary layer, something like this. Okay? So what you see here, the dotted line, the dotted line there is actually the boundary layer. What this boundary layer does is that it will slow down the velocity of the air or the water. So you can see here the curve here. As you go to the surface, it will become 0. Alright? So it's a gradual increase, and you can see when the air goes into the boundary layer, it will slow down the velocity. Outside of the boundary layer, then it will be the same velocity, but inside it will be slower. Yes, because the concept of boundary layer is that at the surface, here, at the surface, the velocity is 0. At the surface itself. So it slowly goes up. And until when it's outside of this boundary layer, it will be the exact velocity. But within inside the boundary layer is a lower velocity. Okay? So, I mean, in your explanation, you can also talk about the boundary layer. Can you make it smaller, make it bigger? Does it help if you change the size of the boundary layer? Okay. So this is what I meant just now. The boundary layer, it will transition. When at the initial part of your car, let's say the frontal part, mainly it will be a laminar flow. But as you move faster, because of canister, you punctuate and it push your car forward, you will reach a highest velocity that you will slow down. So your flow might transition from a laminar to a turbulent flow. Okay. So this is something that you will see if you talk about the boundary layer. Okay. And how does the boundary layer affect the drag? I think this is something that's quite important. So a boundary layer, it can be a laminar or turbulent boundary layer. So a laminar boundary layer means that the flow is smooth, is orderly. Alright? In that case, your skin friction drag is low. But one thing about laminar flow is that it might separate if your shape is poor. Means that, let's say if your shape, you have a sudden increase in height, or a change in your shape, it's not streamlined, it will force it's easier for the separation to happen. So once the separation happens, what happens? Any idea? Yes, drag will increase. Because when the separation happens, means that the pressure will have a low pressure region. So your car might be pushed up or pushed sideways, that will decrease the performance. Okay. And if you have a turbulent boundary layer, the flow is chaotic, it's mixed. Your skin friction drag is high, but sometimes it's a good thing. It can delay the flow separation. That will reduce the weight. Okay. And what about the thick or thin boundary layer? So imagine you have a thicker boundary layer. Your skin friction drag is low, but the chance to separate is high. And if you have a thin boundary layer, the skin friction drag is high, but you can delay the flow separation. Okay. So you can see here it's contradicting, right? Yeah. So in other words, when your car is moving, there's actually a mix of laminar and turbulent flow. Okay, but in both also have their pros and cons. So in other words, you need to balance. All right, you need to make sure that the laminar flow, all right, is happening throughout your car, all right, and at the end of your car, the flow doesn't separate. Okay, so that will give you the lowest drag. Okay, so some parts of your car might be turbulent, but if that really reduces the flow separation chance, then that's okay. Okay. So these are some of the tips. Okay, so you can reduce make it a smooth surface, avoid sudden steps. Don't design your car it's like suddenly there's a step height going up or down. So those will disturb the flow of the air. A good example here for flow separation. Okay, so you see a lot of F1 cars, right? You can see that they don't just have one aerofoil, right? You can see the top, the A, is just one single foil. You can see that the flow separation will tend to happen because it's a laminar flow, and it will separate from the surface. You don't want that to happen. So what they actually do that is if you see some of the frontal part of the F1 cars, they have multiple smaller, instead of one big foil, they have 3 smaller foil here. Okay, so this will make sure that the flow does not separate. Okay, and that will reduce the wake zone. The most important thing is you want to reduce the wake zone, which is where the low pressure. So in your NCs later on, Mr. Karwan, he will show you like how do you actually get find the wake zone and all. Okay. So in other design concept is that when you design the bottom of your car, you can actually, when it's at the rear end, then you can make it move up a bit. A gradual move up, you can see at the P there, at the back there is slightly going up. Oh, so sorry, this is a different case. This one is the top there, you can see that it's more streamlined. And you see the P1 at the top part region. The top part here, there's like a spoiler here going up. So that will actually increase the weight of this region. Okay. So use a smooth rear table. So don't make it like you think it's nice, you just make it like go up. Cantik kan? Cantik tapi dia performance tak baik. Okay. So you make sure that you must know the
spoiler tak guna.
Okay. Other methods that they use to reduce the flow separation is that some they might use some flaps. If you see your cars right in the hood, so you can see that some they have a certain flap like that. That is actually to reduce the flow separation. So you can see here the red part. You can see that here is more gradual, but here is a sudden drop. This sudden drop here, here the flow cannot actually follow, it will detach from the surface. So this part here is a low pressure region. Okay, and this will create, the A will create a high drag. Alright. And also the cars, right, if you want to make it nice, you put like some body kit at the bottom part. Nice, right? But actually it will disturb the flow of this. You make it separate. So you must really make sure that when you design something, make sure that there's a functional use, not just that it's nice. Make sure it's functional, and also you don't want to add, unnecessary spoilers or like foils or stuff like that. So you want the wake region to be as small as possible. Okay. Any questions? Okay. No questions. We can go into the Bernoulli principle. Can anyone explain to me what the Bernoulli principle? You get something. So what happened when the velocity increased? Anyone? Yeah.
Okay. Velocity increase, your pressure will decrease,
Right. So if your velocity increase, because p plus half rho v squared, if your velocity increase, your pressure will decrease. Okay. This will affect the lift and the downward force. Okay. Any question on the Bernoulli principle? Have you learned it in your school? Ada belajar? Ada. Bernoulli principle. Yes, right. Okay. So when your velocity increase, your pressure will decrease. Okay. So this will actually affect the lift, the downward force, and all this because it will either push your car up or push your car down. Okay. So do we want lift or do not want lift here? You want lift? If lift, then your car will be away from the track. It's not an airplane, okay? So you're racing on the ground, so you don't want too much lift, okay? So if there's too much lift, your wheel will be detached from the ground, then your car will be moving, alright? So that will cause an instability. Okay? So you don't want, you want a bit of, because there's some downward force, you might want a bit of lift to balance out, okay? But you don't want too much lift. So yeah, the design consideration is try to avoid the shape that looks like an aircraft wing. Okay? So that is the Bernoulli principle. And for the force is similar as the drag force, the same kind of formula. So in other words, you want to avoid like you make like two wings on the design that looks like an aircraft wing. Okay? So this lift force, yeah, and also you try to avoid upwards tilt surfaces. Later on we'll talk about that. Or if a surface is too much tilt, we talk about the attack of angle. Okay. Sorry, the angle of attack. Correct. So too much of the lift force, it will reduce the wheel contact with the track. So it means that your car now is like flying, alright, instead of on the track, going to the finish line. Okay. So you reduce wheel contact, you also make the car unstable, and also, but you need to maintain lift and downward. What happens when there's too much downward force?
Increase friction.
Yes, you have a high pulling resistance, okay? Because you're pushing your car down to the track, you have more resistance also. So ideally, you want your lift and downward force to be balanced to each other. Okay. And when we talk about Bernoulli principle, a more specific one is the Venturi effect. Have you heard of this Venturi effect? No? Yes? Okay. So basically, it's using the same concept as the Bernoulli principle. Alright? So lower velocity means higher pressure, but it goes through a smaller channel. So this will increase the velocity, but lower the pressure. And when you expand it out again, you get lower velocity and higher pressure. So question here, when do you actually see this Venturi effect on the car? Anyone can answer that? Get something. When do you experience this Venturi effect? I mean, which part of the car, if you can explain? Yeah? Anyone else? If not, he will keep answering the question. I give chance to other people first. Ed, any idea? Yeah? Huh? Wait. Which part of the car that you actually will see this effect? Okay, I got it first. The top, not really the top of the car.
Type je Venturi dalam bahasa Melayu. Kalau tak faham bahasa Inggeris tak apa. Kau faham bahasa Inggeris kan? Buat bahasa Melayu. Kalau tak faham bahasa Inggeris, buat bahasa Inggeris. Nanti dia akan bagi penerangan. AI yang akan jawab kan. Tu dia beritahu.
But is there
Tu.
something, because
Ah.
you see the battery effect, right?
Yang penting kau
Both
faham.
sides are solid, then there's an edge.
Kau tak kau dengar kau nganga je kau putih atau apa pun tak faham. Macam tu lah belajar. Sebab nanti kau nak buat macam design engineer dia kena buat dia punya tu.
Yeah.
Konsep.
Answer. Yeah, the diffuser part, which actually means the bottom of the car. Yeah, the underbody, yes, correct. So you get something. So basically, where this
Padunya kau punya nulis ni. Form 2 dah belajar.
because you imagine your
Fluid
car
engineering
and
semua
your
dah
body
belajar dah.
in between there's a gap. So this gap actually promotes the venturi effect. So you must actually design, like just like I show an example, right, like a diffuser. So if at the end of the car you open up again, so that will reduce the velocity, make the pressure higher. Okay. So this venturi effect is good if let's say you want to put a foil, something to push it down. So this venturi effect will actually push your car down also. So it occurs at the bottom of the car, right, and the track, right, and any tight spaces between the body, as long as you got two different parts of the body squeezing the air. So that is when the venturi effect comes about. Okay. So when you design your car, you must make sure that so you want to make it nice, right, at the bottom or somehow more complicated. But sometimes you make it too complicated, that will mess up with your pressure. Alright, is it low or high at the bottom? That will create a V-force or a double force. Alright, so you want to take into account for that. Okay, so example here as a diffuser, as what your peers mentioned. So the diffuser here, you can see, take a look at the P. It actually open up again, so that reduce the speed, right? So the pressure will increase. Okay, so that will reduce the weight zone. Okay. Good. Anyone have any questions? You can ask if there's any question. Alright, so let's go into friction force. Okay. So friction force is basically the force that opposes the motion. So when you go, if there's no friction force, what will happen? Any idea? If there's no friction force, your car will continue to move forward all the time. Okay? But in actual fact, you always have a frictional force. Okay? Have you all learned about normal force? Yes? No? Yeah. So normal force is basically, you can see that every object has a weight. Correct? So the normal force is basically the same but opposite direction of the weight of your body. So that means that if your car is heavier, is your normal force higher? Higher, right? So if your normal force is higher, that will, how does it affect the frictional force? If your normal force is high. You can see the equation. Frictional force equals to coefficient of friction times the normal force. So if your normal force is high, your frictional force is high. Yeah, that's the concept behind it. So you don't want your car to be too heavy also, because that will increase the frictional force. Okay. But the coefficient of friction depends on what? What does it depend on? Any idea? Any idea? Coefficient of friction?
Only coefficient of friction. Coefficient of friction.
You answer, you get something. Yeah.
Coefficient of friction.
Yeah. So coefficient of friction depends on the surface roughness. Okay. How rough your surface is, basically any two surface in contact your surface roughness is will affect the coefficient. So the rougher the surface, the higher the coefficient. So in other words, for the frictional force, it depends on the surface and also depends on the surface roughness and also depends on the weight of the car. Okay. So where this frictional force will come about is that between your wheel and the track, the axle and the wheel and the body. So when you assemble your wheel, right, you make sure that it don't touch the body. And the paper line contact also. Those will create the frictional force. Okay. So one thing that you can make sure is that when you spin your wheel, if you realize that there's any, like you spin it, you realize there's some resistance, that means that it's touching somewhere. Okay. So that will create friction. Right. And you need to align your axle correctly also. What happens when your axle is not aligned? Any idea? Axle is the rod that holds the two wheels. It is not aligned. Okay. Yes, the car is stable. Alright. So when it moves unnecessarily, that will create the frictional force also. Alright. Yeah, so these are all some of the design considerations that you need to make sure, alright? The wheel can spin freely, it doesn't wobble. Those will increase the performance of the car. Alright, vertical forces, as you know here, is the normal, the downward, and the weight. Okay. So too much, you need to balance your downward force also, because the downward force, if it's too high, as what your friends mentioned, it will increase the rolling friction. Alright. And you need the normal force to maintain the stability of the car. Make sure that it is on the track. And you don't want too much speed. Okay. So all this you need to really take into account when you design the car. Make sure that it's not tilting, not going up, not going down too much. Sometimes you think that okay, the car is going downwards, I mean like it's not lifting up, that's okay, but that will increase the performance. Because if you have too much of the downward force, that will increase efficiency. Okay. Attack of angle, have you all heard of this? Okay, what do you know about attack of angle? Okay, so attack of angle, okay, but you know how to calculate attack of angle? Okay. Have you all, you know how to calculate the angle of angle? No? Okay. So basically how to calculate the angle of angle is that if you have a design something like this, basically first thing you need to do is you need to draw the chord line. Chord line is basically at the end here to the frontal here, this is one line. Okay? So you draw this chord line, which is the orange line, and you draw a line perpendicular, parallel to the surface, right? So that will be your flow. So this alpha angle here is the angle of attack. Okay. So when you position this design of your car, right, this foil, you must make sure that the angle of attack is not too low, not too high. That's optimized angle. Okay. Because what will happen? It will affect the lift and the drag. And when your lift is too much or your drag is too much, that will affect your performance. Okay. So in general terms, a small angle of attack will guide the flow. But if it's too big, it will cause the flow to separate, and that's to give a high drag. Okay. So some example here is that if your angle of attack is too low, on the left side, you can see that although there's very low drag, alright, but there's a minimal downward force. There's not enough downward force for it. So what will happen here is that your car will tend to lift up a bit, right? So your car won't travel as fast, right? And when the angle of attack is too high, Okay, you can see that now the drag, alright, is too high already, so it will promote the flow separation at the back. Alright, but there's a lot of downward force, but the drag is too high. Okay, so you must find an optimal this angle of attack so that it gives you just enough downward force, right? The middle one gives you enough downward force, and also the drag is not too much. Okay, so how the angle of attack come about here? If you take a look at the back of the car, then there's a wing there. So that wing actually you can see that different angles that will affect the flow. Okay. Right. So now the next one. How do we design the front part of the car? There's a formula here.
Masya
Does it look complicated?
Pelik.
Very complicated. Okay. So basically, what this
Pengsan
X
formula.
series does is that it's a formula. When they design the rocket going up to space, right? They design the nose tip. They use this hex series as a guideline to design that. Okay. So basically, you want to design how much of a curve of your frontal surface here. So there's a hands-on activity here, alright? So if you manage to complete this, you get some tips also. So this hands-on activity is that you need to use a formula to calculate it. And the constraint here is that the total length of the frontal. Okay. So which means that you take a look at if you look here, right? At the top part here, your nose starts at here 0, but it ends at here 10 mm for the side view. But you see the blue line, how it goes there, how much it curves, that can be calculated. It's not just simply draw a curved line. Alright? And also for the top view, alright, how big of the diameter here? Since the radius is 10, the diameter here will be 20 mm. So this will also define the top view profile of your nose region also. Okay. So I want you to try to complete this. You can write on the table. Then if you get all correct, then you get something. Okay. So you calculate from 0 to 65 mm interval.
Formula ni. Kau klik formula ni.
This is the formula.
Belajar lah buat formula ni. Berapa dia punya bacaan.
Okay, this is the formula. Calculate this, the radius and the diameter.
Buat dia punya formula tu, isi form tu. Berapa minit nak buat? Belajar. Ini advance weh. Nanti korang boleh buat dia punya nose cone depan tu. Kereta depan tu macam canggih sikit lah. Formula dia. Ambil kat ni formula dia.
You can do using Excel, it's fine also.
Pakai Excel lagi senang.
But Excel will be faster.
Pakai ni AI je, kau tak gambar dua tadi. Kau guna AI je. Lepas tu kau tukar nilai.